All right.
I don't know about every night, but I probably will.
Section 1:6, last section of chapter 1 we got today. Yesterday we talked about angles, and all the angles that we saw yesterday are individual angles. So we said like acute, obtuse, straight, right, all of those were like single angles all by themselves. So this section is still going to talk about angles, but now we're going to talk about pairs, angles that are together and make a certain type of pair. We're going to see a lot of these angles as we go throughout the year, and some we'll see more than others. The first one is adjacent. Okay, adjacent, if you break down the word adjacent means next to. Okay, so it might be like the house next to me is adjacent to my house, right? And so when we talk about an adjacent angle, here is an angle. It would be these two angles right here. Okay. Notice I put different markings on them because they're not necessarily congruent. This angle and this angle are different angles, but they are next to each other. So essentially what's happening here is they share this side. This angle here and this angle here both share a common side. They have a side in common and they have a vertex in common. We talked about the vertex yesterday is where the angles meet at. And so there the angle shares a vertex and a side. Okay, complementary angles are two angles that add up to be 90 degrees. So first of all, we've got to have a right angle. Okay, that would be the angle that we saw yesterday. And then if I take a ray and go to the inside of this angle, okay, it doesn't have to be right down the middle. It doesn't have to be 45 and 45 to make a 90. It could be 60 degrees and 30 degrees. It could be 70 and 20. Any combination that adds up to be 90. But they do have to add up to be 90. So the key here is that they make a right angle. So if I see this little square in the corner like we talked about yesterday, then I know these two angles together are making 90. Okay, supplementary. The way I kind of like to remember this, if you're trying to remember your vocab and remember the differences between all these. Yesterday, what did we call an angle that was 180 degrees? Straight angle, right? Because it makes a straight line. So two angles together that make a straight line are what we call supplementary. So they both start with S. So that kind of helps me to remember supplementary and straight go together. So we have a straight angle. We have 180 degrees. We have a ray that comes off of it. Maybe this one over here is 120. Maybe this one here is 60. But they add up to be 180. Okay? And that's just one example. It could be anything that adds up to be 180. Same thing up here. Maybe we put 70 degrees here, and maybe we put 20 degrees here. Some combination that adds up to be 90. Could be a lot of different possibilities. Okay, the difference between supplementary and linear pair. So if it was supplementary, they would not necessarily have to touch one another. It could be like this. These two angles still add up to be 180, but they don't necessarily have to have a shared side. If they are adjacent and make 180, then they make a line. And so then they would be a linear pair. Okay, so that would be the difference between supplementary could touch. We would still say these two are supplementary. Either way it's drawn. But now because they're touching and because they together make a line, we call them a linear pair. Okay, out of all of these angles that we're going to talk about, this one right here is probably going to be, I would say, the most important because it's going to be the one that we're going to see the most. Okay, we're going to see it the most out of all these angle pairs as we go throughout the year. Okay, and this is not really a formal definition. Okay, this is just kind of what happens. When two angles are vertical, the angles that we are referring to are two angles that are directly across from one another. Okay, and when we think vertical, we think about getting up and down, right? So it could be these two that are directly across from one another, but it could be two on the other side, either. So whichever way, but it's the two angles directly across from one another. And they are equal. Okay, so if I tell you that this one is 60 degrees, this one is 60 degrees. The same would be true for these two here. These two would also be as well. So you have two pairs of angles that are congruent. Okay, I might even, let me throw this one up here. Let's say I draw this and this. Let's say I label these four angles, 1, 2, 3, 4. That's not the angle measure, that's just the number of the angles. So we would say angle 1 is congruent to angle 3, and we would say that angle 2 is congruent to angle 4. Okay, two pairs of angles that are congruent. Austin.
So say this was like the like, as this is one of our answers, would we have to like put it exactly like that for it to get right, or if like we missed like one of the like angle signs, would it be wrong?
Yeah, probably not. It kind of depends on how the question would be asked. If I just said which two angles are congruent, then you could just say 2 and 4. You wouldn't necessarily have. But yeah, just kind of depends on the situation. Yeah. And the good thing about vertical angles is we don't really need any information. If two lines cross and make an intersection point, there are two angles formed that are congruent, two pairs of angles together that are congruent. Okay. So once again, we see one of these common errors. In this case, DAC is this one here. DAB is this one here. They share a common vertex and a common side, but they also share interior points. So they are not adjacent angles, okay? The adjacent angles here would be DAC and CAB because they share the side in between the two. Okay? In this case, what they're saying is that DAC and DAB both share DA, but the points on the inside of the both would be the same. When I look at adjacent angles, the points inside of here and the points inside of here would be different points. Okay, so the interior of it is different. It's not going to have any shared interior. So a pair of adjacent angles, in this case we just talked about it, angle DAC and angle CAB. Okay, complementary means two angles that do what?
They like parallel. They complement each other.
They got up to 90.
They add up to be 90. Okay, so we need to find two measurements that add up to be 90. So if I look at these three numbers, what two numbers could I put together that would make 90? 53 and 37. So we're going to name the angle that makes 53. What would be some names for this angle right here, based off what we did yesterday? It is acute, okay? But when we talk about naming it, we're talking about naming it with its points. Okay, when we named angles, what would be one way I could name this angle here?
RST.
RST would be good, okay? What else? Can't name an angle R.
I said TS.
Oh, TSR would work. Yep, you could go the opposite direction.
SRT.
Can't go SRT because S has got to be in the middle. Okay, angle S would be all right too because it's its own. It's all by itself, right? It doesn't have any shared angles. It's one angle all out there by itself. So I could call it SR, RST, TSR, or just angle S. Any of those would be fine. Okay, and I only tell you that because there's more than one way to name it. So we could go a lot of different ways. Okay, so we said 53 and 37. So when I name the 37-degree angle, I would say angle CAB. Or BAC. Okay, either one of those would be fine. Okay, supplement means they add up to be 180. So what two numbers would I need to put together to make 180? Braylon? 127 and 53. So I would say angle CAD and angle RST. Just make sure they add up to be 180. All right, next page. A little bit different picture, but essentially it's doing the same thing we did just a second ago. Adjacent. Okay, adjacent. Which two angles share a common side?
FGH and KGH. H.
Not quite. Okay, they do share FG, but that's kind of like what we talked about on the last page, is the interior points would be the same. Okay, so there has to be a ray or a line that cuts the two off. So they're two separated angles.
What did I say?
FGH and KGH, I thought?
I said FGK and KGH.
Okay, maybe I just misheard you. Okay. So then it would be FGK and KGH. Okay. There's nothing special about the angle measures, but they share that side in between. Okay, that's what makes them adjacent, right next to one another. There is no angle right next to this guy, right? It's sitting here. There's nothing on the other side of it that we could match up with it. So it's got to be these two angles here that we're looking at. Okay, once again, complementary. We're looking for two numbers that add up to be 90. What two?
49 and 41.
49 and 41. Okay. What could I name this angle right here?
Angle G.
Can I call it angle G?
No.
Hey, we don't want to say angle G because could I also call this one angle G? Yeah. And so those are two completely different angles, right? This one's 41 degrees, this one's 131 degrees, and if you say angle G,
KGF.
KGF, okay, or FGK, okay, and down here, can I call this one angle K? Yeah, because it's the only angle at angle K. There's no other angle there. So if I wanted to, I could just say angle K. That'd be the quickest and easiest way to name it. Okay. I also could call it GKL or LKG.
Wait, because K is like the only one with one angle on it.
Yep.
Okay.
Yep. Exactly.
That makes sense.
If I were to draw another one like off of there, like that, now there's a couple angles that happen at K. Okay, and then supplementary, what two values add up to be 180? (131 and 49). Okay, so what could we call the 131 angle? Okay, KJH or KGH. And once again, put it with angle K. Okay. But I talk about the naming because there are a lot of different ways to name some of those angles, okay? And so as you try to name it, if you have one thing and I have something else, we might be talking about the same thing. And so just keep that in mind. Okay, don't confuse name with angle measures. When we talk about angle 1 and 2 here, we're just naming angles 1 and 2. We're not saying that is the measure of the angle. If I want to talk about a measure, I always got to put a degree symbol on it. In this case, 1 and 2 don't have degree symbols on it, right? 62 has the degree symbol. The key here is the word complement. Okay? If something is a complement of something else, it's different, right? It's not saying, hey, you look really nice today. That's a pretty nice compliment, right? That's a different kind of compliment. This complement talks about angles, and what word does it really look like that we just talked about today? It's kind of a abbreviated version of which word that we talked about on page 1.
Complementary.
Complementary, right? Okay. So what is complementary?
Two angles add up to 90.
That's right. So what we're saying here is one of the angles is 62. So if I were to write out a statement here, I would say angle 1 and angle 2 are 90 because they are complementary.
Right.
And we know that angle 1 is 62 degrees. We're trying to find out what angle 2 is. So I just call it x because that's our unknown. So I'm just trying to set up an equation that we can now solve. Is this a hard equation to solve? No, just a one-step equation, right? What would I do to get x by itself? Subtract 62, okay? And that would leave us 28 degrees. Okay, same thing here. Just break down the word. Supplement, what does it look like? Well, it looks like supplementary, right? The one we talked about on the previous page. Supplementary means they do what?
The two angles
Add up to be 180. So in this case, we would say angle 3 plus angle 4 add up to equal 180. We are trying to find angle 3. We know that angle 4 is 47. Since we don't know angle 3, I'm going to call that x. You can use whatever variable you want. Angle 4 is 47 degrees, and they add up to be 180. Okay? So now if we want to try to get x by itself, once again, it's just a one-step equation. We subtract 47 from 180, and we're left with 133 degrees.
You saw that time.
Okay, I'm going to redraw this picture because I think the picture can be a little bit deceiving. 5x minus 10. We've got the soccer goal that's kind of leaned back. Or I guess it's not a goal, but it's a bounce back return. BCE is the angle that's being formed right here. That is this angle right here. That would be 5x plus 10. This angle here is 3x plus 2. We don't just want to assume, but in the directions it tells us those two angles are supplementary. So what's that tell me about those two angles? They add up to be 180. Okay? So we're going to go 5x plus 10 plus 3x plus 2 equals 180. Okay? Once again, it just goes back to our algebra skills again. Okay? We're going to use a lot of those algebra concepts that we used back in Algebra 1. We've got to be able to solve equations. If you're still struggling with solving equations, make sure you come in and get some help. I'll be glad to help you. Okay? I'm going to tell you right now, one of the biggest mistakes, and we saw this yesterday and I didn't talk about it a lot, is the 5x and the 3x are on the same side as one another. And one of the most common mistakes that I'll see people do is they'll subtract the 3x from the 5x. But we don't do that because they are on the same side of the equal sign. Here's that equal sign, right? Because they are on the same side of the equal sign, we're just putting them together. Okay? And so 5x and 3x makes 8x.
You would do the same with like numbers?
Yep. Do the same with the numbers. 10 and 2 makes 12. So we're combining things together that are on the left-hand side. There's nothing over here to combine because it's just 180. Now I have a two-step equation, and now I can solve. So now I'm going to subtract 12. And 168 divided by 8 gives me what? Okay, and as I told you yesterday, there will be some times throughout the year where we might just say, what is x? And we would be done. Okay, here I want to find the measure of those two angles. So the measure of angle BCE would be 5 times 21 plus 10. Because we're talking about this angle right in here, which is 5x plus 10. So we do 5 times 21 plus 10. Which would be what? 115. Okay. And then to find the measure of ECD, we would do 3 times 21 plus 2. 65. Okay, how could we check our work here to make sure that our answer makes sense? Yeah.
115 plus 65.
Yeah, and what does that make? 180, okay? If it doesn't make 180, then that's a big red flag, right? Something's wrong. We want those two to add to be 180, okay? So on something like that, you should always be able to check it. If it doesn't work out, if it doesn't add up to be 180, that means you probably did something wrong. Okay, this one does not have a picture, but what we know is LMN and PQR are complementary, and once again, complementary means they are going to do what?
Go out to 90.
Add up to be 90. So I'm going to go 4x minus 2 plus 9x plus 1 equals 90. Just make sure we put the right number in the equation, okay? They have a sum of 90. Once again, they are on the same side as one another. So 9x and 4x makes 13x. Negative 2 plus 1 is negative 1. Add 1 to both sides. Divide by 13. Get x equals 7. Okay, to find the two angles, 4x minus 2, we would do 4 times 7 minus 2, which would be 26. And then angle of PQR, 9 times 7 plus 1. Okay, and once again, not a bad idea at the end just to double check to make sure that it works. Okay, if those two don't add up to be 90, something's not jiving, right? 64 plus 26 should add up to be 90. So that, for one thing, that's a kind of a nice thing to be able to do, to check that. Okay, I don't think I'm going to go through this one here. We've already kind of done a couple of these already. The only key here is that they are supplementary, so it's 180. So it would be kind of like 2 problems ago that we did. Okay, so we're going to move to this one here. Identify the linear pairs in the diagram. Hey, so a linear pair is 2 angles that 2 things have to happen. Okay? Number 1, they have to share a side. Number 2, they must be supplementary. okay? It must add up to be 180. Well, there's no angle measures given to me here. So we can't just look at the angle measures and say, oh, these two together make 180. So we're looking for two angles together that make a line. What two angles put together would share a side and make a line?
Does it have to be two angles?
It has to be two, because everything here is pairs. 1 and 4, okay? And that's a good question, William, because 2, 3, and 5 do make 180, right? But that's three angles and we only want two. So in this case, we would say angle 1 and angle 4. Okay, are there any others? Or is that the only answer?
1 and
4 and 5.
4 and 5.
4 and
Yeah,
5.
there we go.
I thought
Okay.
it was 1 and 3.
Okay, 1 and 3, 2 is actually between them.
Yeah,
Okay.
that's what I was.
Yeah, so if you added 2, but then we would have 3 and we can only have 2. Okay, but 4 and 5 would be another one. Okay, so on some of these, possibility of having more than one right answer. Okay, vertical angles. So when we look at vertical angles, number one, they have to be directly across from one another. Number two, they would end up having to be congruent. Okay, and we don't know any measures here, but it's where two lines intersect and it's the two angles directly across. So could I use 4 with anything? Is there an angle directly across from 4 that I could match it up with? No. If I put 2 and 3 together, yes, right? That would work, okay? So 4 doesn't work. What about angle 1? Is there one I could match up with angle 1? 5, okay? The one that is directly across from angle 5 is angle 1, 5 and 1. Okay, what about 2? Is there anything directly across from 2? No. 3? No. So the only pair that we have here is angle 1 and angle 5. It's the only possible answer. All right, these last couple are good old story problems. We have to be able to read through it, kind of decipher the information that we want, and we want to set up an equation to come up with an answer. Okay? Unfortunately, the equation is not given to us. And the reason why this is different than the other ones that we did, it's going to be very similar in the solving aspect of it, but the reason why it's different is we don't have any expressions. Or the expressions are written out in words. Okay? The expressions are going to represent a statement or an expression. And so here's what I like to do. I like to say x is the first angle. Okay? I don't care what variable you use. X is usually my go-to, but you can use m if you want to for measure of an angle. I don't really care. Okay? When we compare the two angles, the measure of one angle is 5 times the measure of the other. So if I tell you that x is the first angle, what would be an expression that would represent my second angle?
5x.
5x, okay? It's 5 times bigger. So 5 times x is my second angle. Okay, the other piece of important information here. They make a linear pair, okay? Boss, what does it mean to be a linear pair? Okay, think linear. What's linear mean?
Two angles that create a line.
Okay, so what do you think that means? How many degrees in a line? How many degrees in a line? Okay, so these two angles together make a linear pair. Okay, you could draw a picture if you want to. The picture would look like this. These two angles together are making a line. Okay, you don't necessarily have to have a picture here, but x plus 5x equals 180. So then, if there's nothing here in front, we assume that to be a 1. So that makes 6x equals 180. And then we divide by 6, and we get 30. So the first angle is 30. So to find the second angle, what would my second angle be? 150. 30 times 5. So the first angle is 30 degrees, the second angle is 150 degrees. Okay, to check this, two things would be true. Okay, this has to be 5 times bigger, which it is, right? Because we just multiplied it by 5. And then second thing is these two angles together have to add up to be 180. Okay, I keep coming back to that because that is something that you should check, right? If they don't add up to be 180, I have done something wrong, especially on these story problems like that. Okay, try the last one. See if you can set the last one up. Be careful of the wording. I'll give you a minute or so to try to set it up. See if what you guys can do. Use what we did on the last one to kind of help you out.
Yeah.
All right, Garrett, what would be an expression for the second angle?
No clue.
Okay, what does it say in the problem?
Oh, well, 5x plus the second angle.
That's this one. We're down here.
First angle,
What's this mean right here?
twice,
So what's that mean?
twice of 180, 180.
Okay, are they going to add up to be 180?
Yeah,
Okay, what does this mean?
180.
Complement is a form of
150.
complementary, and complementary means,
I have no clue.
okay, Austin, what do you think? Help him out.
It's 2x.
2x, right? 2x is the second angle. Okay? 2 times bigger. So now, the key here, the key word that we're looking for is complement. The last one was linear pair. It could be complement, supplement, linear pair. There's some different variations today. So in this case, x plus 2x have to add up to be 90 degrees because they are complementary. Add the x's together, combine like terms, divide by 3. Okay, so if this angle here is 30 degrees, then the bigger angle has to be 60 degrees. Okay, 2 things have to be true. This is 2 times bigger. Yep, makes sense. 60 and 30 doesn't make 90? Absolutely. Okay, so that's how we can check our answer. All right.